Okay, so what you're doing today is we're learning about section 11.7, which is the surface area and volume of cones. The first thing we need to do is we need to understand what each one is. Okay, so the surface area of a cone, there's two surfaces. There's the base surface, which is a circle, and you know the area of the circle is just pi r squared. And then we have this like slanted cone part outside, and that's called the lateral surface. And so the surface area is equal to pi times the radius times lateral height. Or not lateral height, but yeah, lateral height will work. It's the slant height. So it's the slanted side, okay? Plus pi r squared for the base, because it's a circle. So we might have to use some Pythagorean theorem to find that slant height. Okay, so the volume of a cone is nice because it's the same thing as the volume of the prism. It's 1/3 the area of the base times the height. And because this is a circle, the base is always pi r squared times the height. And here's the height. The height is that perpendicular height through the center of the cone, or the height from the cone to the vertex, as long as it's a right angle. Okay, so let's do some formulas. Okay, so surface area. And again, if you write the formula each time, you will probably have it memorized. That's how I'd like to memorize things. Just keep writing them over and over again. Okay, so pi, I'm going to leave them in terms of pi because it's more accurate. So times 3. This one, it gives me my lateral, which is pretty nice. Keep saying lateral instead of slant. Okay, so 3 times 5 is 15, so it's 15 pi. Plus 3 squared is 9, so it's 9 pi. And 15 pi plus 9 pi is 24 pi. And so it's 24 pi centimeters squared, because area is something squared. Maybe we should add up here. And this is units squared. This is units to the third. Okay? All right, let's try one more. And so it's going to be 1/3 times pi times my radius is 3 squared times my height of 4. So that's 1/3 pi times, this is 9 times 4, which is 36. And 36 divided by 3 is 12. So it's 12 pi centimeters cubed. And that's it. When they get harder, it's because you have to find the slant, which is this little Pythagorean theorem. Okay? What I would like you to do is I would like you to try in your surface area and your volume down here. You don't have a picture, but see what you can fill in, and then I will come back and help you. Okay, so the things that you could have plugged in, you should have been able to plug in your R, which is 0.9, because it's half of the diameter. Probably don't know your L yet, your slant height, so we'll find that. Okay, so if you notice, I have a right triangle right here. And this is 3, and this is 0.9. So now I'm just going to do Pythagorean theorem. So not x, but I don't know the slant, so that's x. So 3 squared plus 0.9 squared equals x squared. So those together make 3.81. And so x is 1.95 after I take the square root. So then I'm going to just kind of squeeze that in. And so now I'm just going to do my multiplying, and I get 1.755, so I'm just going to say 1.76. And then 0.9 squared is 0.81. And so now I add those together, and I get 2.57 pi inches squared. So there's an example where you had to find the right angle. Okay? And then why don't you go ahead and do this one on your own and press play when you think you got it. Okay, so you should have plugged it in and got 0.9 squared times 3, which is 2.43, which when I divide by 3 is just 0.81 pi inches cubed. Okay? So I'd like you to try number 3 again. Start off by drawing the picture. This picture's a little different because it gives you the slant height, which is this slant height. and it gives you the radius of 5. So now you're going to use Pythagorean theorem to find this side, the height of the cone. And then once you do that, you're able to find both answers, the surface area and the volume. Okay, so for surface area, you should have been able to plug it in without solving for x because you don't need the actual height. And so you get 65 pi plus 25 pi, which gives you 9 pi feet squared. For volume, you're going to need that height. So let's see what you got for the height. Okay, so what you should have saw for the height here, you should have gotten 12 using Pythagorean theorem, and then you plugged it into the volume, and then you should have got 100 pi feet cubed. Okay, so 5 and 6 is a little different because we're going to solve backwards, so I'm going to walk you through those, and then you have examples. So the surface area, so I'm going to go ahead and write my surface area formula. So pi r, I always do squared, pi rl plus pi r squared. Okay, so now I'm going to plug in what I know. I know surface area is 400, radius is 7, and I need to find slant, so I should change that color. This is what I'm looking for. I'm looking for slant. Okay, so let's plug everything in and do a different color. So 440 equals pi. And if you notice, they don't have a pi in this answer. So instead of pi, I'm going to use 3.14. Radius is 7 times L plus 3.14, 7 squared. And now I'm going to do some math. 3.14 times 7, and then 3.14 times 7 squared. And so I get 21.98 times L plus 153.86. And now it's just a basic equation where you're going to subtract. And then I'm going to write it over here because I'm running out of space. So 440 minus the 153.86 is 286.14. Now I divide. And so your slant height is, let's see, divide 13.01. So we'll just say 13 inches. And that's it. But again, you had to start with the equation. So for number 6, same idea. I'm going to start with the equation. So volume is equal to 1/3 pi r squared height. Let's see what we have. We're given the volume, and we're given a diameter. And so that means the thing we're looking for is the height. Okay, and again, this volume, they did not have pi sign, so we're going to use 3.14. So 528 equals 1/3 times 3.14 times my radius squared. Well, if my diameter is 12, my radius is 6. Okay? And so now we're going to do all that math, multiply all those things out, and I get 528 is equal to 37.68 times h. And now we just divide. And so while these problems look overwhelming, if you start with your original formula and plug things in, they're not that bad. But you need to start with that formula and just start plugging stuff in. So this is also 14.01, so I'm going to just keep it at 14. The reason it's probably 14 is because 0.01, because they probably use the pi button versus 3.14, which I'm using. Okay? Questions? If so, go back and look. I think you can get it once you watch it again. Okay, 2 more examples. So cone A and cone B are similar. The radius for cone A, so A has a radius equal to 4. B has a radius equal to 10. This one, A, has a volume of 134. And B has a volume of, we don't know. So remember when we have done similar figures, if it's just side to side, it's a side over side. But when you go to surface area, it's side squared over side squared. And when you go to volume, it's volume side cubed over side cubed. So since I'm looking for the volume of B, so I'm going to put that on top. That's in the same place as the volume of A. And now I go back to B, and I'm going to do 10 cubed over 4 cubed. And so 10 to the third divided by 4 to the, oops. So 10 to the third divided by 4 to the third. That is, so 134 is equal to 15.625. And now I just times both sides by 134. I don't think this is a hard problem. What's tricky is remembering to do side cubed. So this one is 2093 and 75 cents, and that's the volume. Oops, and I should put in there centimeters cubed, so if I can squeeze it in there. Okay, so again, volume is side cubed over side cubed. All right, last thing, we have two shapes. So I got my cone, and my cone volume is 1/3 pi r squared height. And then I have my cylinder, which is pi r squared height. I think that you could do these, see what you can find, and then press play. Okay, so when you plugged in the cone, you should have gotten 16 over 3 because the radius is 2. And in the cylinder, the radius is also 2. And so now 16 divided by 3 plus 20, well, 16 divided by 3 is 5.33. So when I add these together, it's 25.33 pi inches cubed. So remember the thing with composite figures or solids, you want to find the volume of each one and then figure out if you're adding or subtracting. If one's inside of the other, you're going to subtract. But if they're connected and they're all outside of each other, then you add. Okay? So I don't think these are that hard. I think the biggest hint for all this is always just write the formula. And then you're just plugging in numbers.